Hey folks, Quill18 here, and welcome to another Unity 3D tutorial for tile mapping. In our last video, we looked at generating a very simple texture to apply to our actual terrain mesh, and we're still one step away from starting to generate sort of more proper actual maps, you know, either Civ style or dungeon crawler style, but we're getting very, very close now. Now, right now we are generating random pixels to supply to our texture, but we don't want that. We want to create our first actual tile map or tile atlas or sprite atlas. There's many different terms to sort of mean the same sort of thing. And for this, we're going to need some sort of painting program. Absolutely anything can do. You can use just the default paint that comes with Windows, and that will work fine. I will use Photoshop because that's just what I happen to use, but you absolutely do not need anything this fancy at all to get this done. Now, I have decided that based on the retro feel that I want for my game, I want each one of my tiles on the map just to use 16 pixels. I want them to be, I want them to be 16 square pixels, 16 by 16. And I've determined that is going to be plenty to get all the graphic fidelity that I want in my particular game. So I'm going to go File, New, and I'm going to start just by creating 16 by 16. This is going to be my tile size. I'll go ahead and set a white background, and I'm going to have this microscopic little dot, which I will now zoom into. And this will be my default tile. Now, to start off with, let's say we want, I don't know, I guess we'll do, I'm not sure. Well, I'm going to just create 4 random color squares so that we can actually see what's going on. Let's pretend for the moment that we're doing a civilization style game. That'll be fine. So I'm going to want a sort of nice green here for my... I'm going to start off this way. I'm going to fill it with the paint bucket. So I've got a nice green thing. Ignore the lines. It's not actually there. That's just showing the actual pixels. So I've got a solid green square is what I've got going on. Now, that is just one tile. Now, I could save this out and have one graphic file for this one square. There are many performance reasons that make it so that you don't just want one little tile in one file by itself. We want to create one file that has many tiles in it. So what I'm going to do is I'm going to change the canvas size of my image, and I'm going to show this current stuff over to the left. You'll see what I'm doing in a second. I'm going to switch all this to pixels. I'm going to change the width to 64. This will give me enough room to have 4 tiles side by side. Boom, right, like this. Oh, I don't like this. One sec. I'm going to unlock the background just so that when I redo this... Oh, I gotta change all my defaults. I just upgraded my Photoshop, and none of my defaults are correct. You go over to there, 64. And all I'm gonna do is I'm gonna take my one image here. I'm just gonna duplicate it. I'm gonna go 4 times. Again, you don't have to be as fancy as what I'm sort of kind of doing here. And I'm gonna take my graphic and move it here. I'm gonna take the next layer and move it there, and then the final layer and shove it there, and then I'm going to go and grab my paint. I say, okay, we need we need water, obviously, right? So actually, I'll make the first one water. I'll leave the second one grass. The third one will be maybe we'll have plains, which will be some sort of, I don't know, orangey yellow. And then the last one it will be some sort of mountain, which everyone knows is gray, right? And then, you know, if I want it to be really fancy and highbrow with my graphics, I could say, oh, with my mountains, let's change the size here. This is gonna be a peak. Great, that is beautiful. And my grass over here, we're gonna use a darker green, and we're going to we'll draw on some grass. Right, and it's fuzzy because the actual size, there, that's at actual size. Right, so I've got mountain terrain, I've got my plains, I've got grassy land, and I have my ocean. Fantastic. So now I'm going to save this. We will save it, and I will go to, let me shove it over here for a sec. We will go to my C drive where I have my files. Go into my TileMap tutorial folder. Okay, so this is my TileMap tutorial. I'm going to go into Assets, and I will create, I'm going to create a folder called Textures. and I'm going to save it right in here. I'm going to call this my my sieve map textures. And I'm going to save it as a Photoshop file because Unity can read that fine, but a PNG or a JPEG or whatever format, in fact, you can use like bitmaps or targas. These are generally, things like a bitmap or a targa are uncompressed file formats, so they tend to be very big, but you can tell Unity to compress these things, or by default, actually, Unity will compress these things when you publish your game. It's the same thing with the Photoshop files. So I'm going to save that. It's going to be an unnecessarily large file. When I go into Unity, it'll take a second to import that, and if I go over to the textures subfolder, it's right there. You can see the format is set to compressed. So whenever I publish the game, it will compress these images, so it won't actually send the original Photoshop file in there. So the size is nothing to worry about. Okay, so we've got this tile map, which is great, sort of, and we want to have it so that when we generate this thing, instead of using a single color for a dot, we want it to use these tiles here. Okay, fine, great. Let's go back to our code. Okay, this is our tile map code, and we have to feed it a little bit of information. We need a placeholder because it's going to need to know what this texture file is. So we're going to create a public texture 2D, and we're going to call this our terrain tiles. There, that works just fine. And we, you know what, that's going to be fine. So now if I tab out, and I click on my map, there should be a placeholder for the texture 2D. Great, I can drag that right in there. So now my map generation script is going to know where my tiles are coming from. And this is a 2D texture, and I can get some information out of it. So, for example, the texture width and height, I can figure that out from the file. Now I could ask myself, right? I could put this a public over here, and I could call it tile resolution. And I mean the correct answer right now is 16. There are 16 by 16 pixel tiles, right? I could also say something like public int num tiles. And again, right now the correct answer is 4. There's 4 tiles in that terrain. So I could ask those, and that would certainly be one possibility, but some of that could also be calculated from the actual tile map. We kind of sort of need one or the other. It's probably best to have it asked there, because one thing, okay, if this terrain tiles is a strip like this, then I actually don't need either one of these, because what I can do is over here in my terrain, in my function, I can go terrain tiles, and I can get the height, right, which will be 16. Right, this is a 16 pixel high image, so that would give me my resolution, tile resolution, int, right, and then I can do something like int num tiles is equal to terrain tiles dot width divided by tile resolution. And this would return 4. So I'd have 16 by 16 tiles, and I would have 4 of them. This works perfectly fine if you've just got this single strip like this. Now, if you end up having lots of different terrain, and you end up with an image, canvas size, oh, I really have to change these defaults. This is going to be driving me crazy. And let's shove this to the top, and you know, this is quite tall because I have many different tiles that show up down here, and I can save this, right, and use this inside my program. Well, then we're not going to be able to automatically determine all this information. We're going to need to ask at least something, and in this particular case, what we're going to ask the user in the editor to fill out is, hey, what's our tile resolution? Maybe we shouldn't default to anything. I'll just have it be like that, right? So over here, we're going to tell it that it's a 16 by 16 tile, and I can probably apply these changes. We can still calculate the number of tiles. That's pretty easy. So like that. Now this is number of tiles in a row. Number tiles per row, and int num rows. Yeah, num rows is equal to terrain tiles.height divided by, well, same thing. and that'll work fine. Right now, what it'll return for us is number of tiles per row will be 4, and number of rows will be, I'm thinking, 8. But I can also do that. Now it'll correctly return 1 row. Now that I'm back in here. So now, number of tiles per row will be 4, number of rows will be 1 in this particular example. But we can feed it any kind of information there. In fact, in our tile map, depending on what kind of game and how optimized and minimalist we're trying to do, we could have many tiles. We could have, the first row could be all terrain tiles. The second row might be all your unit graphics, as an example. And then the third row might be town graphics and so on and so forth. Or, you know, maybe you have special resources. So in Civilization you can have, you can find iron, for example. And forest. Forest can grow on top of grassland, depending on what version of the game you're playing at. Sometimes forest is sort of its own terrain type, and sometimes it's something that exists on top of existing terrain, right? So some forests can exist on top of hills. And so, you know, you might have these special resources as a separate row. There's many different ways to go about this, right? Going to depend on your particular game implementation. Right, but now we've got that, so that's great. So what we want is we want these graphics to be used on this texture. All right, so that's fine. So we're going to, well, what are we going to do? Our texture width and texture height is going to be, our width is going to be the total size of our map, which right now is 100 tiles, times our tile resolution. So this is going to be a 1600 pixel wide graphic we're creating, and then the same thing this way, size Z times tile resolution, which is going to be an 800 pixel tall image. Now again, I can run this as is, and it'll actually take a little while to run, but other than that, it won't have changed, other than we'll have much tinier things. Now it really looks just like static, right? Because every pixel in here is set to a random number, and there are many pixels in here that are quite tiny. All right, so that's a start. This loop is entirely wrong, however. We don't want to loop pixel by pixel and set them to a random color. We want to loop tile by tile and set them to a tile from our terrain tile texture. All right, so we're going to change our loop. Our Y and X loop is going to be based on the number of tiles as opposed to the number of pixels. Right, that's one. Then what are we going to do? Well, we are going to grab a random tile from our terrain tiles object. And how are we going to do that? Well, we want to get some pixels from it. So there's a get pixels function. Again, this does not necessarily represent the most optimal way of doing it. In fact, there's a huge inefficiency here, but we won't worry about it now. We'll look at it a little bit later. So we want to get some pixels from our terrain tiles object. Now, if I just call get pixels like this, it will get all of them. But I actually want to specify a position. And for now, let me just grab the very first one. We're going to force it to grab the first one, which is water. So that is going to be, we can pass it coordinates. So we're going to start at the 0 point, and the block width and height, well, that's our tile resolution, and tile resolution. So we're going to grab those pixels, and what are they going to get stored at? Well, they're actually an array of colors, unless I'm mistaken. But I'm pretty sure I'm remembering this correctly. Yes, it returns an array of colors. So we're going to store that in P, and then we are going to apply that to our actual texture over here. So our actual texture, which right now is this object here, we're going to set pixels, which we were doing before, but before we were setting set pixel singular, which just needs one coordinate and one color. Well, now we're going to set pixels, and we can feed it an array of colors. Now, if we just feed it the array by itself, it will just be applied sort of to the default texture. In fact, I think if I did it with this array, it would crap out, because the pixel array here, would just be a 16 by 16 area, and this is expecting a 1600 by 800 pixel object, which we're not going to give it. But we can specify, again, a version with X and Y coordinates and a block width and height. So, well, let's just feed in the 0 again, and let's set the tile resolution, and then for the colors, we can feed it our pixels object like that. Now, this will loop through every single tile in our map, but we'll only actually set one of them over and over and over. But let's try to run this and see what happens. I'm hoping that we get an object that is entirely white, except for one corner. Now that is green because that's our little helper function, but I don't think that it actually worked. Oh, there's an error. Set pixels has an invalid. What is wrong? Oh, what is this? There we are. Let's try to run this again. Oh, I didn't actually want to hit play. I wanted to hit. Let me clear. Grab this, hit regenerate. Okay, so we are still getting an error. Now, what is this error? This is something that you're definitely going to see the first time you try this. It is saying that there's a texture that's not readable, the memory can't be accessed from the scripts. You can make the texture readable in the texture import settings. So what does it mean? Well, okay, our texture that we are creating right here in our script, we can interact with this. We can grab pixels and we can set pixels. We can do all those things. However, the textures that we access through the editor that exist here, for example, right, and then get assigned to an object here, by default, these are not editable in the editor. They're stored in a slightly different way in memory. They're optimized differently. They're stored on the graphic card or whatever. Unity is responsible for sort of managing this object, and it makes certain assumptions. If you don't need to interact with the pixels yourself directly, there are certain optimizations that Unity can do that it's quite happy to do. However, in this case, we need to be able to read the actual pixels in this texture. So over here, with this texture selected, we have to go to the inspector. We have to go to Advanced, and then we have to hit the checkbox that says Read Write Enabled. Boom. And if we run our generation program again, let me clear all the errors. If I hit Regenerate, we should now not get that error. We might still get a different error. It says done and done and done. Oh, it did draw something. You can see under a square that's actually blue. Where's the tile selection indicator? Let's shove it out of the way. There we are. There, now we can see our one blue pixel right there. Or not blue pixel, this is actually a tile. This is a 16 by 16 pixel area of this texture has been set blue. In fact, it has been set blue 5,000 times. You know, it's the same area every time. Now, obviously, that's not what we want. So let's take a look at this. So we don't want to always set the 0, 0 pixel. We obviously want to use our X and Y. Right, our X and Y. But we don't want to use it directly because X and Y is just looping for every tile. So it will loop from 0 to 100 for the X and from 0 to 50, well actually 49 for the Y. So we have to multiply this by our tile resolution. Right, so the first time it's going to run, it's going to start in 0, 0. The second time it's going to run, it's going to start 16 pixels over, right, because X is going to be equal to 1. So 1 times 16, so it's going to start 16 pixels over, and then 32 pixels over, and so on and so forth. So now, if I run this, it should set absolutely everything in our screen blue. All right, let's give that a try. Regenerate, and the whole map is blue. Now, this is because it is setting every single tile, every 16 by 16 tile from our object here. Now, we're still just grabbing this first block. What if we didn't grab the first block? Well, let's grab the green one. So the green one is 16 tiles over, right? 16 pixels over in here. So let's just change this X to 16. Let's make sure that it's working the way we think it works. Regenerate. Boom! Look at this. Now it's filled with grass. Our ugly, ugly grass texture. Okay, and then it becomes really obvious that this tile, this pattern is repeating. And in fact, what we can really do at this point is we can use the normal bilinear mode if we wanted to. And this would smooth out some of the pixel artifacts a little bit. There we go. So it's a little bit more blurred and softened, but as we zoom in, well, it's going to have some issues with the clipping over here. I mean, we're somewhat zoomed in over here. but it should really sort of smooth out the pixels. And again, a big thing here comes, what kind of game are you making? If you really want that retro-ish feel where you can see the pixels, you do want that point. This is not generally going to be the right answer. Here, because I've got such a low resolution thing going on, I will go ahead and use the point resolution nonetheless. So again, we've got that sort of very pixely kind of look going on. In fact, on YouTube, you may not even be able to see the difference between one and the other just because the compression might be blurring all these pixels anyway. All right, so that's good, but obviously we don't just want the same terrain repeated over and over and over. We want to, well, for now, let's just apply some randomness to which tile gets selected. So there's a few different ways of doing it. The best way, actually, is for us to chop up this terrain object ahead of time. So what do I mean by that? So we are going to return, there's a bunch of different ways. Let me think on this for a split second here. How do I want to return this? Because what we can do is we can do something like terrain. Hold on, int. We're going to call it terrain tile offset, and we're going to do something. We're going to pick a random number from 0 to 4. Well, actually, it's going to be from 0 to 3, and we're going to multiply it by the tile resolution. And this is going to be our offset, right? Now, again, we're still just using random generation at this point. Oh, random.range. All right, so it's still going to be like pretty much nonsensical noise. But there we go. Now we can definitely see, right? The tiles are working properly. Zoomed out, it looks like a big old mess. But the tiles are actually working. So now it becomes more of a question of how do we actually generate, good-looking continents, for example, or if you're in dungeon crawl, how do we get the rooms and the corridors to go? And unfortunately, that's a really complicated question to answer because it's mostly going to depend highly on your game. But we will look at a few techniques in the next video. Just a couple more things I want to address. So right now, we're grabbing these pixels every single loop. This is not optimized. What we'd almost want to do, in fact, what we want to do is chop these up ahead of time. So I should probably build a helper function for this. Let's do that. It's going to be called chop up tiles. It's actually not going to be a void. We're going to change the return type soon. So what we want to do is we have this information. We have number of tiles and rows and all this. Chop up tiles is going to be responsible for just handing back a set of pixels that we can just pick from. So it's actually going to return an array of colors. And it's in fact going to return 4 of these because our pixels are an array of colors, right? So it's going to be an array of those. So we've got this information, so we're going to create color tiles, new color. We're going to create a new array of these, and it's going to be based on number of tiles per row times num rows. So we've got a new array ready to hold some pixels. And so what we're going to do now is create a for loop, int y equals 0, y is less than num rows, y plus plus. For int x equals 0, x is less than num tiles per row, x plus plus. So in our terrain tiles, we're going to grab x times that, y times that, the right size block, and we're going to store this in y times num tiles per row plus x. And we're going to return that. So let me go and explain what this is in just a second. Let me make sure there's no compilation errors. I'm as shocked as you are. Really. So what this is doing is it's going to loop through our terrain tiles object. It's going to pull out every chunk of pixels that is a tile, and it's going to return those. And what we're going to do is we're going to store them over here. It's going to be color tiles equals chop up tiles. And here, instead of doing the get pixels over here, because we already have those all sorted out, is we can do, we're still going to assign it a temporary variable just to make it a little bit more clear. But we can say tiles, and we're going to grab one of them. We're just going to say, because we know we have 4. So we're going to say random range from 0 to 4, well, 0 to 3, obviously. And that should work the way this is already working. And in fact, it is. Now, this is still not the right way to organize it, because the thing is, we don't actually have any tile data right now. The game has no idea that these graphics represent grass and water and plains and mountains, and therefore we can't use this to build an algorithm that makes a beautiful continent, for example. It's just not an option. So the next step is we have to change the way, or we have to create a way to hold that terrain data. And basically we're going to throw away most of what's going on here. And the reason is, so far we've just been working this sort of Unity side of things, right? Where this is all part of a mono behavior, it's all part of this, our editor button, and so on and so forth. We want to hold this data in just sort of generic data somewhere else that's completely disconnected from the graphic information, right? The terrain engine shouldn't need to know about pixels. It should only be aware of this is grassland, this is water, this is a mountain. It should be able to generate all this information in a data layer that is disconnected from the graphic layer, and then at some point when it finishes, it says, great, I've done this, and then the graphic system will look at the map data and convert that into, okay, so this tile here, this tile data is, this is tile type 3, which is grassland. Well, I know that the pixels for grassland are this, so I'm going to show this on screen. And there's a lot of reasons that you want it to work that way. The primary reason, well, I don't know if it's the primary reason, but one of the things is it's going to be a lot faster, right? When you're working on data that is, because there's a lot of data, there's a lot of tiles going on here. So you don't necessarily want to be shuffling objects around in memory that have lots of graphic information. You just want, you want somewhere that says water is terrain 0, grass is 1, plains is 2, mountains is 3, and so on and so forth. And it's much easier to work and sort of shuffled with this data. It also means that your actual data layer is kind of system agnostic. If later on, right now we're working this sort of 2D graphic basically, right? I mean, we really are. It happens to be on a 3D mesh, but it's a very 2D-ish kind of system. Well, later on we might want to we might want to rip out the graphic engine completely. Maybe we don't want to do it in Unity anymore. We're going to want to do it in a different system so that we can do it specifically 2D, like not a 3D engine at all. Or we want to flip it around and add a lot more mechanics to how this works. Maybe, for example, we want to go into a much higher resolution type of situation, and we want our grass to actually start blending. And that's one of the things that modern strategy games like this do quite well. If you go into Civilization 5, for example, you don't see this line where your plains and your water and your grasslands or your mountains sort of connect, right? It blends nicely one in the other. And the reason is that the amount of space a single tile takes up might be, well, it's not, here it's 16 by 16. In those games, they tend to be a lot higher because the graphics, they just have higher definition graphics, basically, that they're using, so they get really nice blades of grass. But the graphics are actually larger than the strict tile space as well. They overlap one another. And so, your actual map engine, the thing responsible for creating your map data, doesn't need to know that, oh, we want to overlap the grasslands, or where the grassland and the water meets, we want to make it look like a beach and have nice rounded edges, because, water, will obviously have sort of flattened this out so that it'll be nice and round. And maybe we want sort of wave effects that go up and down. And, and here we want a nice smooth transition between the dry plain plains and the lush grassland, right? Those are things that the graphics system cares about. The actual game engine doesn't give a hoot. And so this is why you want that sort of separation between the your data layer and your presentation layer, right? Or a sort of view model type of setup, depending on the lingo that you're using as a programmer. Now, some of these things apply to something like a civilization type game, and in a dungeon crawler, these sorts of hard edges tend to work pretty well in a sort of roguelike game. So we're probably actually going to experiment a little bit more with that, because the graphic stuff, I mean, it's so fiddly and specific to what you're doing, right? But and how do you actually blend the pixels one and the other? And there's far more level of complexity. If you need that sort of thing, then it's going to be beyond the scope of this particular tutorial. So we are going to look at basically throwing out this particular demo and moving over to the sort of dungeon crawler kind of look, because it'll be a little bit easier to work with. Now, one of the other things that I haven't really discussed is what happens if I have... Actually, no, that's fine. I was about to tell you stuff that wasn't actually true. One of the issues that's going on right now is no, that's not true either. Your graphics, your texture does not actually have to match the size of the actual mesh. Right? Right now, we have this mesh where every single one of these tiles is a square, but there's no reason that has to be the case. In fact, when we first started this example, we were using, well, let's use the built-in plane, Unity's built-in plane. And let me shove it over here and blow it up real big so we can see it side by side, 100 by 100. Oh, right, I forgot that it's already 10 times bigger than it should be. But no, that's fine. So we've got this Unity plane, and you'll notice that the squares, it's made up of a mesh of 10 by 10, right? Whereas our actual map here is 100 by 100 currently. But we can take the same material and apply it to this square, and it looks fine. In fact, if I resize this to be 50 by 50, there we are, and put these two side by side, you cannot tell the difference between the two of them. And why is it? Why is it that the one on the left, the tiles, the actual polygons match the tile, and it doesn't over here? Well, because it doesn't have to. This could literally be a single quad, right? A pair of triangles, right? 4 vertices, one in each corner. And the object will map perfectly fine as long as the UV coordinates are just set there. And so if you are making a terrain map, if you're making a civilization type of game, and you don't need any actual sort of height and bumpiness in your texture, there's no reason that you can't just use 2 triangles, 1 quad. So 4 vertices, 1 in each corner, and you'll be done. The only reason we need this mesh, and we want the mesh to match the textures, is so that we can make our mesh bumpy. In fact, if you recall in the previous demo, we did that here. Our vertices, our Y is currently set to 0, but again, we can go random.range and say that it'll span from -1 to +1, and then regenerate this, and now we should have a nicely lumpy map, and everything will look appropriate because our pixel tiles match our mesh tiles in a one-to-one sort of relationship. We wouldn't be able to do that and have it look like this if the tiles didn't match. I'm hoping everyone sort of follows what's going on there. Now, one of the other reasons this works so smoothly is because we just have one mesh where everything is connected. If we look at sort of one of these triangles over here, in this setup, in this quad, this mesh tile, this vertex is the same vertex that is used over here, right? This is one vertex that happens to be shared by, well, it's actually shared by 3 triangles, because there's this triangle, there's this triangle, and there's this triangle. I almost feel like I have to go back to my paint graphics. But there's one vertex. The advantage is that this whole mesh doesn't need quite that many vertices to sort of define everything. The problem is that if we wanted a sharp break, if we wanted this tile to literally like float above the rest and not have these smooth sort of connections, you wouldn't be able to do that. You would have to create separate vertices for this triangle and these triangles and break them up. In this case, you could have these adjacent triangles at completely separate heights. Probably not making much sense. Let me break out the paint. All right, time for some art. Right, so if we go into this sort of perspective, really? You're doing that to me? Never mind then, let's not use lines. We go into this sort of perspective view like this, so we have one triangle here, and we have another one here, another quad, right? And of course these are made up of two triangles, but let's just think of quads. So if I take this one vertice, with this one vertex which is shared, and move it up, then both of these quads will become sort of angled, right? They'll both be curved because that's shared. Both of them get their corner pulled up. Same as if I took a piece of paper and just sort of tugged in the middle, the whole thing would bend upwards. However, if it was in the same setup, but this was one unique vertice, or vertex, I always get the plural mixed up, and this quad actually had its own, and then I grabbed one of them and moved it up, then what would happen is it would break. In fact, if I took all of these and moved them upwards, then what I would have is the one square still here, and then the other square sort of floating above now. You can't, they work differently. The problem with this approach is that you need many, many more vertices. That means it takes up a lot more memory. Depending on what kind of game you're trying to do, you're going to want one or the other. So keep that in mind when you're designing your generator. So over here, the number of vertices would be quite different, because you would need 4 vertices for every actual tile. So that would actually be the math here. You would just say num tiles times 4. So I probably just, confused everything, and I really apologize for that. But on to the next tutorial, where we look at how one might store the actual map data information and create a map that looks vaguely interesting-ish and realistic. We're not going to go and create, a fully featured map generator, because there's no way to do that in a generalized way. It's going to depend entirely on your game, but we'll talk about a few techniques for pulling it off. See you next time, folks. Bye-bye.